Hi everyone, today I'll be doing the term 1, week 7 mechanics CA quiz. So we're going to start off with question 1. So question 1 basically states that a block of mass 40 grams, okay, is submerged in oil at a depth of 80 meters. Given the density of oil, this rho means density, is 950 a kilogram per meter cubed, and G is what, 9.8. Now the pressure, you know, the basic formula is pressure is equal to rho G H, right? We have all of these values. We have rho, which is 950. We have G, which is 9.8, and we have H, which is 0.8. Now this gives me 950 times 9.8 times 0.8, 7,448 Pascal. But here they wanted what? Kilopascal. So what are you going to do? You're going to divide by 10 to the power of 3. You're going to get 7.448, and they want to one decimal place, so 7.4 is our answer. Okay, moving on to question 2. I don't know why SDP is being slow. Never mind. No, yeah, it is being slow. Don't even load the question. 1 second, let me let the question load. Okay, so turns out the question 1 I solved was actually question 2, and this is actually question 1. So I solved question 2. The mass of a rubber ball is 48 grams and its volume is 40 milliliters. What is the density? Now you know that density is what? Is mass over volume, right? And they want it in kilogram per meter cubed. So first, gram to kilogram, divide by 1000, right? So it's going to be 48 times 10 to the power of negative 3. Okay, now milliliter to liter is how much? Divide by 1000, right? Divide by 1000. But now, milliliter to liter, but this is not to meter cubed, right? Yeah, okay, so I just have to confirm it real quick. Yes, milliliter to meter cubed is divided by 10 to the 6. Okay, this is milliliter to meter cubed. Now, essentially why? Because 1000 liters, you know, is 1 meter cubed, right? So this is how much? This is gonna be 1000 times 10 to the power of 3 milliliters, right? So convert it like this, blah blah blah, you get it. I'm not gonna go into details, just remember that. Now density is mass 48 times 10 to the power of minus 3 over 40 times 10 to the power of minus 6. How much do you get? 48 times 10 to the power minus 3 over 40 times 10 to the power minus 6. 1200 kg meter cube per meter cubed. Okay, that's the answer. Now I move on to question 3, because I did question 2. Okay, didn't I just do this? 1 second, let me figure out what's going on with SDP. Okay, so this is the question. A block of volume 0.03 meter cubed is completely submerged in oil of density 950 kilogram per meter cubed. G is this. Now, they want the magnitude of the upthrust. The upthrust is a force, right? It's a force. Now, as you can see, it's in newtons. The formula is rho Vg, okay? Similar to pressure is rho Gh. This one is rho Vg. Okay, now, what do you do from here? So you have rho 950, you have V 0.03, and you have G 9.8, right? So 950 times 0.03 that's 9.8, 279.3 newtons. They want to the nearest integer, so you just take this. Moving on to question 4. Apply Hooke's law. What? Hooke's law's coming? I don't know. I actually didn't study this because when a block is suspended from a spring, okay, so like this, of spring constant 200 newtons per meter, it extends by 0.08. Given G is 9.8, the mass of the block. Now, you know it's F equals Kx, right? Now, F is my weight, right? Because again, I'm suspending it, so it's gonna go down like this. Now, what is the only force acting here? Ignore the tension up there. It's essentially just this. This is gonna be what? This is gonna be mg, right? mg is equal to kx. K is 200 times m is 0.08. Now, be careful in the example. They might trick you and give you, for example, 80 centimeter. Right? They might give you, well, it's not gonna extend 80 centimeter, like 8 centimeter. Okay? But here, the spin constant is what? Newton, which is fine, per meter. This is centimeter. Remember, always look out for your units. But here they didn't try to trick us. So this is gonna be 9.8, or m, g is 9.8, right? So it's gonna be 200 times 0.08 over 9.8. Do this on your calculator. You get 200 times 0.08 over 9.8. 1.63. To one decimal place, 1.6. That's your answer. Moving on to question 5. Okay, so this is question 5. My bad, I had to pause the video. My SDP is, I don't know what's wrong with it today. So they told me a rod of length 1.5 meters and cross-sectional area of 2.5 centimeters squared is subjected to a compressive force of magnitude 9 kilonewton. As a result, its length decreases by 0.5 millimeter. Now, they want the stress in the rod. The stress we denote it by sigma, small sigma, like this. You know how we had sigma bonds in chemistry? It's like this. This is equal to the force over area, like pressure. Force over area. Okay, my force is 9 kilonewton, so 9 times 10 to the power of 3 newton, right? Over area. Now area is 2.5 centimeters squared. But SI is what? Meter squared, right? So you know that centimeter to meter is how much? 10 times 10, or times 100. Times 100, yeah, times 100, or divide by 100, sorry. Divide by 100. So square it, square centimeter squared and meter squared, you're gonna get divide by 100 squared, right? Why is it not writing here? Divide by 100 squared. Okay, so it's gonna be 2.5 times 10 to the power of minus 4. You know, because if 100 is what? Is essentially 10 to the power of 2, right? So square it, you're gonna get 10 to the power of 4. Since you're dividing by 10 to the power of 4, it's the same exact thing as saying times 10 to the power of negative 4, right? So 9 times 10 to the power of 3 over 2.5 times 10 to the power of minus 4. You get 36. What is this? Million? 1 second. This is settings. Wait, calc settings. Here it is. Digit separator on. This is 36 million. Yes, which is 36 megapascal. Okay, because this is 36 times 10 to the power of 6. And remember, times 10 to the power of 6 is what is mega, right? So instead of writing times 10 to the power of 6, you just write megapascal. Now, the strain in the rod. The strain is represented by epsilon, which is the E, as in physics, for EMF. Now, this one is the length, the change in the length, delta L, over the initial length, L. But it's not with a sign, no, it's magnitude. So here it decreases by 0.5 millimeters, right? So it's going to be 0.5 times 10 to the power of minus 3. Over L is originally 1.5 meters, right? So over 1.5. Now, this gives you 0.5 times 10 to the power of minus 3 over 1.5. 3.3 times 10 to the power of minus 4. Okay, now, I don't need all of this anymore. So I'm just going to erase it because now I need to find the Young modulus. Now, first let me write what I found first. I found that sigma, or stress, for now on I'm going to refer to stress as sigma because it's faster to say. 36 times 10 to the power of 6 Pascal, and my epsilon, and instead of strain I'm gonna say epsilon, is 3.3 times 10 to the power of minus 4. It's unitless, okay? So, epsilon is unitless. Now, the Young modulus, we refer to it as E, is the ratio of the stress, or sigma, over the strain, which is epsilon. Okay, so we're just gonna do that. 36 times 10 to the power of 6 over 3.3 times 10 to the power of minus 4. What do you get? So, 36 times 10 to the power of 6 over 3, or over answer, because I want it to be exact. You get, no, let's just use 3.3 times 10 to the power of minus 4, that's what they gave me. You get 1.09 times 10 to the power of 11. 1.090, yeah, okay. It's fine. Now, here they told me, first of all, 110 is wrong. It's supposed to be 109 because the next digit is a 0. So you're not even rounding. I don't know how they got 110. It's a multiple choice answer, right? It's a multiple choice answer. So what's the closest answer to 109? You have 110, right? So you're just going to put 110 anyway. I'm assuming they just wanted to round to like these values. Anyway, they wanted to take two significant figures. That's probably why, yeah, they took two significant figures. Okay. Now that we know that they took two significant figures, so this is actually just 1.10 then, right? But this is times 10 to the power of 11 Pascal, which is an awkward unit, because remember, our prefixes, we have kilo, mega, giga, and etc., right? So we like to use these prefixes. We don't like to use awkward, like times 10 to the power of 9, or no, times 10 to the power of 9 is a thing. Times 10 to the power of like 6, that's another thing. 7, there we go. Not 6, 7. You get what I mean. This is awkward. This is awkward. We don't like it. So what we're gonna do, we're gonna take 2 out. So we're gonna have 110. And then this becomes what? Times 10 to the power of 9 Pascal. Right? Times 10 to the power of 9 is essentially just giga. Okay? That's essentially, times 10 to the power of 9 is a prefix for giga. So my answer is 110 gigapascal. Moving on to question 6. Okay, question 6 finally loaded for me. It's memorizing and it's really easy. The external force or weight applied to a material or a structure is referred to as load. Just know it. Just like refer to it whenever you need it. So it's just any external force or weight that you apply to a material or structure. Now, the increase in length obviously is going to be called an extension, right? And then you have a decrease in length. Extension and compression are common sense. Now, the maximum load or stress beyond that a material can withstand while still exhibiting a linear relationship between stress and strain. Oh, what? This isn't a sentence. Maximum load or stress that the material can stand. Like, why are you ending the sentence here? There's nothing that you're telling me. This is incomplete. Whatever. I don't know. This is just filler. Beyond this limit, the material may experience nonlinear deformation, leading to permanent changes in its shape called the limit of proportionality. So essentially, okay, it will always go back to its original shape. Okay, so graph it like this, and then you reach the limit of proportionality, it bends off like this. It's no longer back to its original shape. This is what we call the limit of proportionality. Okay, limit of proportionality is, it's in the name, it's proportion, right? They said it's linear relationship. And remember, linear, it can be expressed like this, or sometimes in the case of plus b, but you're gonna have this constant, right? This is gonna be k, so it's gonna be a constant relationship, or not constant, linear relationship with a constant. And what does that mean? You can then always imply that y is directly proportional or inversely proportional depending to x, right? But what is wrong with me today? Once you exceed, remember, we said it was like this. We graph it linearly, then it breaks. It breaks off. This becomes something else. Okay, this is the limit of proportionality. After this, you can no longer say this anymore. It doesn't become linear. It becomes annoying, and we have to figure it out as math. So after that, you don't have any proportionality anymore, right? That's why they called it the limit of proportionality. Now, question 7. Question 7 states, choose the correct answers to complete the sentence below. The temporary change when a force is applied with the material returning to original shape, it's in the name, it's elastic, right? Like, it's, remember a rubber band, it always goes back to being that, like, elliptical shape, it always goes back to being a circle. But if it's permanent beyond the limit of proportionality, we call it plastic deformation, not elastic deformation anymore, right? It can't go back to its shape. My teacher explained it to me in a way that makes it easy. Imagine you are driving a car and you're on the road or texting or whatever. You're not focusing, and you're reversing into a parking lot. You hit the pole. There is a pole behind you that says like "Don't park here" or something. You hit it lightly. You notice, because you're aware. You notice. You touch it, then you drive back away. Right? You drive back away. You go out and see, oh, it's nothing. It's just like a scratch, something like a paint job will fix, right? Now, the steel did bend a bit there, but it was within the limit of proportionality, so it goes back. But say you were not focusing, you're distracted, I don't know, maybe you're drunk driving, maybe, God forbid, and you just keep on reversing back, like you're not aware. You're not aware that you actually hit this pole. So you go and hit it with a great force, right? You assume that you're parking properly. So you're pressing the brake button, the brake pedal and the accelerator in like large amounts of force, right? So what does this mean? That means you're applying a great amount of force. So once you actually hit that pole, it's gonna be a big amount of force hitting it, right? Because that force gets passed on from to you onto the wheels or whatever onto the pole, right? That's how the force gets moved. So it deforms the shape because remember it's a big collision. So this is essentially elastic and plastic. Now I just overcomplicated it, but you know, it's just an explanation. Now, the force applied to a material per unit area is called stress. We know, right? We just calculated it. We said sigma is equal to F over A, right? Which is stress. Now, the amount of deformation experienced by a body divided by the initial dimensions of strain. Remember what we said? Strain is what is delta L over L, which is exactly what this is telling me. Now, a property of material that tells us how easily it can stretch and deform and is defined as the ratio of the stress to the strain, ignore tensile, whatever, is called the Young modulus. Okay, we just answered that mathematically in the previous question. Okay, so question 8 finally decided to load for me. Now, we have a density, or sorry, what? A mixture is made up of 315 grams of glycerin and 150 grams of water. The density of glycerin is 1260 kilogram per meter cubed, and the density of water is 1000 kilogram per meter cubed. The density of the mixture to the nearest integer is this number. Now, how do we find this number? So, you know that density is what? Density is mass over volume. So this is for one substance. Now, how do you find it for more than one substance? Well, logically speaking, it would be intuitive to say that it's gonna be the sum of the masses over the sum of the volumes, right? Because it's essentially just mass plus mass over volume plus volume, because that's essentially just how you find density for more than one mixture. So instead of saying sum of mass over sum of volume, we're just gonna write sigma m over sigma v. Okay, because you know we're in grade 11, we should know how to use terms such as sigma. So this is just essentially telling me the sum of the mass over the sum of the volume. So you might be telling me, but we don't have volume, we have density and we have mass. How do we find it? Well, you know density is mass over volume. So does that mean volume is mass over density? And we don't even need to find the answer. We just need to find an expression, because we can just do this on a calculator then. So let's find it for glycerin. So let's say glycerin is how much? 315 times 10 to the power of negative 3 kilogram, because they gave it to me in kilogram per meter cubed, over 1260. We're going to leave it like this. I don't need to know more. Now, we're going to find the second volume of water, which is what? 150 times 10 to the power of minus 3 over 1000. Right? Now, we're going to do sigma m. So, 315 plus 150, close the bracket, times 10 to the power of minus 3, right? Because in the end, they're both grams. So we need it in kilograms. So essentially, it's 315 times 10 to the power of minus 3 plus 150 times 10 to the power of minus 3. But you can just take the times 10 to the power of minus 3 out, factor it out, do it like this. So it's one step on the calculator, much, much easier. Okay? Now, V, we're going to use these expressions. So 315 times 10 to the power of minus 3 over 1260 plus, actually, don't open this bracket, plus 150 times 10 to the power of minus 3 over 1000. Okay, now do this on the calculator. So open bracket or open fraction. Now open a bracket, 315 plus 150 times 10 to the power of minus 3. Remember to close your brackets. Over 315 times 10 to the power of minus 3 over 1260 plus 150 times 10 to the power of minus 3. Sorry, 150 times 10 to the power of minus 3 over 1000. You get 1162.5 or 1163 to the nearest integer. Now, they told me a different mixture is made of 315 milliliters of glycerin and 150 milliliters of water. Okay, now they want the density of the new mixture. Okay, so, well, essentially speaking, we need to apply the same idea. Density is mass over volume. It all relates back to this. But how does it relate back to this? Well, this time, instead of given mass, we have volume. And obviously, the density of a material never changes. So we have this, we need to find this. Okay, so you can say mass is density times volume. And you just need to compare the masses, right? If you have a bigger mass, then you're going to have a bigger volume. Because what? The density is constant, right? The density is constant. So Now, if you have a bigger mass, obviously you're gonna have a bigger density, right? Because again, the density is constant. The only thing that you're changing is your volume and your masses. Okay, so let's find it. Now, M is rho, which is 1260. Let's find for glycerin first. Into volume, 315. But remember what we said, times 10 to the power of minus 6. Right? Let me just write it out more. So M is equal to 1260 into 315 times 10 to the power of minus 6. Right? So 1260 into 315 times 10 to the power of minus 6. So we have 0.3969 kilograms, or since we want it in grams, right? Because this gave me my answer in kilograms, multiply by 1,000. I get 396.9 grams of glycerin. So immediately I have a bigger value of glycerin mass, right? I have a bigger mass of glycerin. But let's check for water. If water stays the same, then our life is easy. We just compare it like this straight away. But if water is different, then it depends. Is water bigger? If yes, then automatically our mixture is gonna be, the density is gonna be higher. Or is the water smaller? And by how much is it smaller? But that's an entirely different calculation, and let's check now. So 1,000 is our density for water into 150 times 10 to the power of minus 6. Now do this. So 1,000 into 150 times 10 to the power of minus 6. I get, multiply by 1,000, I get M is 150 grams of water. Now 150 grams of water here, 150 grams of water there. The mass of the water is the same, right? So water is constant. Everything in water is constant. Now I just need to compare the masses of glycerin before and after. Now, before I had 315 grams. After I had 396 grams, right? Or 397. Obviously, if I have a constant mass of water and a bigger mass of glycerin, then I'm gonna have a more dense mixture. Why? Because remember, rho, as we said, is sigma M over sigma V, right? M increased, and because why? Because V increased, right? So since both of these increased, anyway, you can say this is directly proportional to this if V is constant. Since M increased, obviously, since we have two increased signs, what is this gonna mean? This is gonna mean this increases too, right? And this is how we know that it is higher than that calculated in part A. Moving to question 9. Okay, so for question 9, we know that, or what do we know? We didn't even read anything. The atmospheric pressure on a certain day is 101 kilopascal. A vertical force of 2 newtons is used to push an elastic balloon below the surface of water. Density 1000 kilograms, you should know that. The balloon rests in equilibrium. The pressure of air inside the balloon is 102 kilopascal. Assume that very small dimensions of the balloon don't change. Use G equals 9.8 meter per second squared. Now, the pressure by the water on the balloon is what? Okay, so they told me the balloon rests in equilibrium, right? So everything, it's like this. It's like this. Okay, it's standing still. Now, what does that mean? Inside the balloon, I have my gas molecules exerting a pressure, right? I have them exerting a certain pressure on the walls of the balloon. This is just the definition of pressure of a gas, right? Now, outside, I have the pressure exerted by the water. Okay, let's say it's like this. And the pressure exerted by the atmosphere, right? This is just very basic, this is what they're telling me. Essentially, they told me in equilibrium, so I can imply this. Now, since it's in equilibrium, technically speaking, the pressure inside the balloon is gonna be what the pressure outside by the atmosphere and the pressure done by the water. Right? So, they want the pressure by the water. We know pressure inside is 102 kilopascal. Right? It's given here. The pressure of air inside the balloon is 102 kilopascal. The pressure of the atmosphere is how much? 101 kilopascal plus pH2O. So what does that mean? Subtract 102 or 101 from 102, you get pH2O is 1 kilopascal. Done. Okay. The depth below the surface of water at which the balloon is held to 1 decimal place is 10.2 centimeters. Okay. You know that pressure is rho GH, right? Now, sorry, I had to cut the video for a bit. Since we know that the pressure by the water on the balloon, right? Because they want the depth below the water. We're relating everything to the water. It's 1 kilopascal. What does that mean? 1000 pascal, right? Or 1 times the power of 3. Now we want density of water. How much is that? 1000. times G, 9.8, times H, which is what we want to know, the depth. So what does that mean? H is 1000 over 1000 times 9.8. Now 1000 cancel out, so it's just 1 over 9.8, which is 0.1 meter or 0.102 meter. Now remember, meter to centimeter, it's times 10 to the power of 2, right? So multiply by 2, 1, 2, 10.2 centimeter. That's my answer. Okay, the weight of the balloon is 0.40 newtons. The magnitude of the buoyant force on the balloon is what? Okay, so for this, I'm gonna draw this. I have water, I have this balloon, and I have this buoyant force here. Why does it keep cutting? I have a balloon with on water, right? Now, they told me a force is used to of 2 newtons is used to push the elastic balloon, right? So 2 newtons like this. And what else do I have? I have its weight, right? I have its weight mg. Now, its weight is, we don't know apparently. Oh, 1 second. Atmospheric pressure on a certain day is 101 kilopascal. A vertical force of 2 newtons is used to push an elastic balloon below the surface of water to its equilibrium. The pressure is this. Oh no, it's given. 0.40 newtons. So 0.4 newtons. Okay. And now you go up like this because this is the buoyant force. So we're gonna write FB. And since it's in equilibrium, you know what that means. Why am I here? Sigma Fy is equal to 0, right? So that means Fb, which is the upwards force, is equal to the downwards force, 2 plus 0.4, which is how much? 2.4. Done. Okay, moving on to question 9, or moving on to question 10. Okay, so this is question 9. Now, a group of students measure the mass and the diameter of a spherical ball to determine its density. The reading on the vernier caliper measuring the diameter of the ball shown below. The mass of the ball is measured to be 204.2 grams. Okay, the diameter of the ball is 2.79 centimeters. How do you find this? Well, this is the vernier caliper, right? Now, how do you read a vernier caliper? So, you see where the 0 mark lines up with the main scale, right? So, here, for example, it is not this. Don't start reading from this. This is very wrong. Start reading from this scale. Now, it's very close to point what? Let's find out. So this is 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7. It's not at 2.8 yet, but it's way after 2.7. So what does that mean? Now, we know that it's going to be very close to 2.8, right? So it's going to be a number basically bigger than 5. But let's not do it like this. So we're going to take 2.7, so 2.7 something, right? 2.7x. How do you find x? You see where this scale, now this scale lines up with this scale. So it sounds confusing, but let's see. So first of all, we know that it's 2.7 something, right? Because, 0 mark after this. So it's 2.7 something. Now, can it be 2.71? No, it doesn't line up here. 2.72 doesn't line up. 2.73 doesn't line up. 2.74 doesn't line up. 2.75 doesn't line up with the up. 2.76 doesn't line up here. 2.8 doesn't line up here. No, this is 2.7, sorry. 2.8 doesn't line up here. 2.9 lines perfectly, as you can see, right? It's perfect. It's exactly matching with the scale up. Like you can see here, the scale down is the scale up. You almost can't even see it. It looks like one line. 2.10 it's very close, but it isn't exactly lined up. You can see here, it's like this. Down here, up, down here and up here, right, the exact same. So it's 2.79 centimeters, and that's my answer. Now, we know the diameter, 2.79 centimeters, right? But what we don't know is we want the density. So what is the formula for density? Density is mass over volume. How do you find volume? We have mass, that was given, right? It was like 204.9 something, right? Like something like that, right? 204.2. So density is 204.2 over volume. How do we find volume? They told me it's a spherical ball, right? So what does that mean? V is equal what? 4 over 3 pi r cubed, right? Now it sounds a bit dumb to go back to the basics, but generally it's intuition. Like when you actually read the question, you see spherical ball, you have diameter, they're like slowly guiding you. Like this is how you're gonna do it. Now we have pi is a constant. We have 4 over 3, it's also a constant, r cubed. Okay, so 4 over 3 pi r is how much? 2.79 over 2. Right? Now I'm gonna keep it in centimeters, right? Why? Because my density unit is gram per centimeter cubed. So I'm gonna keep it like this. Now, 4 over 3 pi r is 2.79 over 2, because that's just r. Now close that bracket and cube it. Sorry. 11.4 centimeter cubed. Now divide 204.2 by 11.4. How much are you gonna get? 204.2 over answer on my calculator. You get 17.95. What does that round to? 18 gram per centimeter cubed. That's my answer. On to question 11. Okay, so question 11. A mass of 150 grams has an internal volume of 200 milliliters. Okay, sorry, did I say a mass? A glass of mass 150 grams. The glass is filled to the sand to the brim, so it occupies the full 200 milliliters. And weight on the scales. The scales read 470 grams. Okay, so how much is the mass of sand first? Before we start anything, we know that the volume of sand is how much? Is 200 ml. Okay, now how much is the mass of the sand? It's simply going to be the difference in the scale mass. 470 minus 150, which is how much? 470 minus 150, 320 grams. Right, now the density of the dry sand is what? Is mass over volume. So 320 over, kilogram per meter cubed. So 320 times 10 power minus 3 over the volume, which is 200 times 10 power minus 6. Right? So let's do that. You're gonna get 1,600 kilogram per meter cubed. Done. Now, a student carefully pours water of density 1,000 kilograms per meter cubed into the glass to soak the sand such that the volume does not change. When placed on the scales, they read 530 grams. The volume of water added to the sand. Well, you know that density is mass over volume. So what does that mean? Volume is mass over density. Right? Now, what's the mass of water? It's gonna be 530 minus the mass of the sand. Right? Minus the mass of the water, which is 150. Right? Times 10 to the power of minus 3. Over the density is 1,000. So how much are you gonna get? Where am I? You're gonna get 530 minus 320. 530 minus 320 minus 150 times 10 power minus 3 over 1,000. 6 times 10 power minus 5, which is not correct. 1 second. Okay, so there isn't a problem with my calculations. I just rechecked everything. So it is this. But here's the thing. This is how much? This is in kilograms, right? This is in how much? Kilograms per meter cubed. So we cross out the kilograms. What are we left with? This is 6 times 10 power 5 minus 5 meter cubed. Right? Now, remember we said from milliliter to meter cubed, you divide by 10 to the power of 6, right? But if you want to go the other way, this is what I just forgot to do. You multiply by 10 to the power of 6, right? So you get V is equal to 6 times 10 to the power of negative 5 times 10 to the power of 6 to change it to milliliters. You get 60 milliliter. That's the answer. Now, the new density of the sand water mixture is, so density is mass over volume. We know that the mass is gonna be 60, because you do 530. How much is the mass of water? 530 minus 150 minus 320, right? Because that was the mass of the sand, and this is the mass of the glass. You get 60 grams, right? Now, 60 plus the mass of the thing, the sand, 320 times 10 to the power of minus 3, right? Because you want to change it to kilograms, because that's what they want, over meter cubed. Now, they told me the volume of the mixture does not change. So this, it stays the same 200 milliliters. So 200 milliliters, 200 times 10 to the power minus 6. Now, do this, you get 380 times 10 to the power minus 3, because 60 plus 320 is 380, over 200 times 10 to the power minus 6. You get 1900. That's the answer. Question 12. How many questions are there in this quiz? Like 22, right? Okay, question 12 says, a metal block of mass 290 grams initially rests at the bottom of a basin filled with water of density 1020 of a string attached to the block is used to lift it. Once the block is lifted, the tension in the string is 2.2. When the block is completely out of the water, the tension becomes 2.9. Use G equals 10. Now, a force exerted by a fluid on a body submerged in it is known as buoyant force. We know this already, right? Now, the maximum value of the buoyant force of the block. Now, FB is also known as the apparent weight, right? So you're just gonna do 2.9, this minus 2.2. You got 0.7 newtons. Why? That's just a formula, okay? It's what we know as the apparent weight, and that's essentially like, you can go deriving it using Newton's laws, but just do subtract these values. Now, the density of the block, how do you find it? First, you know that density is what? Is mass over volume, right? You have the mass of the block, but what you don't have is the volume. Now, what can you do? You have the buoyant force, right? So you have the buoyant force. Now, what did we say the buoyant force is? Rho Vg, right? So if we want to rearrange for V, it is going to be the buoyant force over rho G. Now, the buoyant force is 0.7. The rho is 1020. And G is 10. Right? So what are we going to get? We're going to get 0.7 over 1200, right? Because 1020 times 10. 6.86 times 10 to the power of negative 5. Right? Now, what do we do here? Not too hard. We found volume. We do density is mass, which is 290 times 10 power minus 3 over 6.86 times 10 to the power of minus 5 gives us, so 290 times 10 power of minus 3 over my answer, 4,225.7, which I don't know how they got 4,200. No, like this becomes 4.225. Yeah, okay, 4.23 times 10 to the power of 3, right? Because you take it back to make it, to make it like times 10 to the power of 3, right? Because they gave it to you something times 10 to the power of minus 3, but you have it as just something. So what do you do to find that something times 10 to the power of minus 3 divided by 10 to the power of 3? So you move it once, twice, 3 times. You get 4.225, which is 4.23. That's your answer. Okay, question 13. Okay, my bad, I had to do something for a bit. Now, a U-shaped tube is filled with water of density 1000 kilogram per meter cubed. One of the ends of the tube is closed with no air above it, and the other is connected to a gas pipe. The diagram below shows the height of the water columns in the tube. Okay. Use G equals 9.8 meter per second squared. Now, for a closed U tube, okay, or UN manometer, something like that, I don't know what they call it. The formula is rho equals sorry, I said rho, I think this is P. That's what I paused the video for. It would be rho G H, normal formula, or for the gas it'll be rho G delta H. It's always for these manometer questions, it's always rho G delta H. Now, if this was open, so you see this pen, we'd remove it, we'd write plus P0, where P0 is the atmospheric pressure. Okay, so we're gonna have rho is the water, so this is due to the gas, pressure at the gas, 1000 into G, which is 9.8, into delta H, which is 34 minus 8, because this is the gas essentially, right? This is the only gas, the rest is water, right? So if we know that this whole thing is 34, this whole thing is 38, what would be left for this? It would be the the gas, right? So P0, since it's a closed end manometer, this doesn't exist. We don't have it. Okay, now do this. What are you gonna get? You will get 1000 into 9.8 into 34 minus 8. You get 254,800. I missed something because there's no way this is correct. No, you change this to meters. Change this to meters. So it would be 34 times 10 to the power of minus 2 minus 8 times 10 to the power of minus 2, 0.26. This is the delta H is 34 centimeter minus 8 centimeter, right? So this gives you 26 centimeters. But you want it in meters. You always want to be working in SI in physics. So it will be 26 times 10 to the power of minus 2, which is what, 0.26, right? So now 1000 times 9.8 times 0.26, 2548 Pascal. But what do they want? They want kilopascal. So this would be 2.548 kilopascal. To one decimal place, it's 2.5 kilopascal. Now, the total pressure at point X at the bottom of the tube. So here. Now, delta H should be 34, right? Here, all the way to here is how much? 34, right? So it is going to be P at X is rho 1000, because it's always of the water. G 9.8, H 34. Now, there is no P0, right? Because it's not open-ended. So how much would this be? 1000 times 9.8 times 34. 333. 200. I also messed up. This is 0.34 meters. It's always in meters. I keep forgetting that. It's 0.34. So 0.34. 3332 Pascal. Change it. It would be 3.3 Pascal. Kilopascal, sorry. Now, the end is open. This end here. So now you will be including the plus P0, which what does that mean? It would mean how will this affect the total pressure? Remember we said the pressure is rho GH plus P0, right? So now we actually have this value. What does that mean? This will increase, so this will increase, right? So we will write it will increase. On to question 14. Okay, so this is question 14. The illustration below shows two identical aluminum blocks A and B suspended from ropes 1 and 2 in the liquid. Each block measures 1 by 4 by 10 centimeters. The densities of water and aluminum are 1000 and 2700 to 2700 kilogram per meter cube respectively. Use G as 9.8. Now, choose the correct answer. Upthrust on block A is equal to upthrust on block B. Why? We know these blocks are identical. They told me that they're identical blocks. And we know that buoyancy depends on the density of the solution, or the density of the solutions in the volume of the block or the solid or whatever, and the gravitational constant doesn't depend on them. It depends on these two, right? This is what it depends on. So this is the volume displaced, by the way. It's always that volume displaced, but like, whatever. So since they are identical blocks, they have the same density, right? And they have the same dimensions, meaning what, they will displace the exact same volume, right? So what does that mean? Their buoyancy, their buoyant force will remain the exact same, right? Because again, they're displacing the exact same volume. They have the exact same density because they're the exact same material. And since they have the same dimensions, they're gonna displace the exact same volume. So what does this mean to me? That means since the gravity is a constant, what can I say? I can say that the FB on A is equal to the FB on B, right? So, done. That's part A. Now, part B, the weight of block B to one decimal place. Okay, block B, right? Well, we know that weight is mass times the gravitational acceleration. Now, we know that mass is what? Rho is equal to mass over volume. So, does that mean M is rho V, right? M is rho V, because you multiply by V on both sides to cancel, so you get M alone. So you say rho VG. Now, what is rho VG? If you remember, this is the buoyancy force, but this is actually not the buoyancy force. It is the expression for the buoyancy force, yes, but the buoyancy force in this question would use the density of water. Why? Because remember, it's the solution, it's the density of the solution submersed in. The rho we're gonna use here. Let's not overcomplicate it. Let's not use this. So you're gonna get here M is what you don't know. So M is rho V, we said. The density of aluminum, because we need to find the masses of the blocks of aluminum, right? 2700 times. VE is 1 by 4 by 10. If you don't know, this is the volume. This is an expression for the volume. So what's 1 times 4? 4 times 10, 40. 40. But this is in centimeter. We need it in meter cubed. So centimeter to meter, how much? 100. So centimeter cubed to meter cubed is 100 cubed, which is times 10 power of negative 6. Right? Now, do this, you get 2700 times 40 times 10 power minus 6. 0.108. 0.108 kg. Yeah. Now, W is equal to mg, right? So 0.108 times 10. How much is this? 1.08 Newton. Now, they took it to one decimal place, right? So it will be 1.1 Newton, right? Not 1.08. Now, the upthrust on block B. The upthrust, you know the formula is... let's just see, it's... upthrust is rho Vg. Or, yes, 1 second. Sorry. Yeah. Anyway, upthrust, and if you didn't know, by the way, upthrust and buoyancy, upthrust and buoyant force are the exact same thing. So FB, you can write it like this for buoyant force, or you can write U for upthrust, but it's preferred to write it like this. Okay. Now, again, they are the exact same thing. Same thing. So that means this is the expression. Now, if you want to find the upthrust, you know this formula. What did I say? This is gonna be the density of the solution it's immersed in. In this case, it's water, right? So it's 1000 times the volume of the block, which we found was 40 times 10 power minus 6 times G, which is 9.8. So 1000 times 40 times 10 power minus 6 times 9.8, 0.392, which to one decimal place is 0.4. Done. Now, the tension in rope 2. So the tension in this rope here. Right? Tension in this rope. Remember what we said in the previous question. Tension is the weight minus FB. Right? Because remember, when we found tension was 0.7 in the other question, I told you subtract because FB, this is the apparent weight. We call this the apparent weight. Okay? So if you find the difference in the weights, that's obviously the pulling factor that's happening, right? So what can you say now? You can say that tension is equal to the weight, which is the weight of the block is 1.1, right? Minus the buoyant force is, we said 0.4. 1.1 minus 0.4, 0.7. Now, rope 1 is cut. What is the direction of motion of blocks? So, rope 1 is cut. So now you no longer have anything supporting them. So this is just gone. Will they float or will they sink? Now, we said that the buoyancy force depends on the densities and their volumes, right? We're not going to focus on the volumes. We're going to focus on this. Now, the density of the aluminum is greater than the density of the water, right? So what does that mean? It's gonna sink. You know how water and oil floats. Oil is less dense than water, right? It's gonna float on the top. But here, aluminum is more dense than water. So what does that mean? It's gonna go down. It's gonna sink, which is why they say move downward for both of them, because they're both identical blocks. Question 15. Okay, question 15. A car has on 4 tires and each tire is in contact with the ground over an area of 130 centimeters squared. UG equals 9.8 meter per second squared. If the pressure exerted by each tire is 140 kilopascal, then the mass of the car to one decimal place is what? Okay, so first I would like to find an expression, right, for one tire, because then we can multiply it by 4 to get the mass. So, you know it's exerting a pressure of how much? 140 kilopascal, which I'm going to write as 140 times 10 power of 3 Pascal, right? Now, you know force is what? Or sorry, pressure, which is Pascal, is force over area, correct? Now, Force, what's my only force acting here? If it's at rest, right? It says it's resting. So I have my car. 1 second. Not the best drawer in the world, as you can see. I have my car. There's no force going like this. There's no force going like this. There's only this. Only my what? My weight. Right? Now, what does that mean? My weight is my only force, right? So F is equal to W, which is what? mg. mg. So mg. Now G is how much? 9.8. So instead of G, I can write 9.8. And then M we don't know. Over area. So what does that mean? My M is what I want to find. My mass of like essentially one like a quarter of the mass. Whatever. You'll see what I mean. I'll multiply this value by 4 anyway. So you're gonna do PA, you're gonna take A up and then divide by 9.8. Right? I'm just finding an expression. Now, this is for by one tire, right? By one tire. Now, each tire has this exact same expression. So what does that mean? When you add them, you're gonna get 4m, right? And this is actually gonna be the mass of the car, which I'm gonna call capital M. So then this becomes 4PA over 9.8, right? Because remember, the original expression was PA over 9.8, but since we have 4 of those tires, what are we gonna do? We're gonna multiply it by 4. Now, 4P. P is 140 times 10 to the power of 3. Actually, I'm going to move this up. I'm going to write up here. So I'm going to write here M is equal to 4 into 140 times 10 to the power of 3 times my area. My area is 130 centimeters squared. But remember, centimeter to meter, how much? Divide by 100. But square it, you get 100 squared. 100 squared is how much? Times 10 to the power of minus 4, right? So it's 130 times 10 to the power of minus 4 over 9.8. Now, do this on your calculator. So 4 into 140 times 10 to the power of minus 3, or times 10 to the power of 3, sorry, not minus 3, into 130 times 10 to the power of minus 4 over 9.8. You get M to be 742.9 kilograms. Done. Question 16. Hopefully the rest are just easy questions. The figure below shows the same block resting on its smallest side A at first and its on its largest side A prime. Compare the forces F prime and F. Well, obviously they're gonna be the same, right? Because again, it's resting, right? So what's my only force? The weight. The weight is not gonna change. It has mass M here, it has the mass M here. Why? It's the same exact block. So my force is gonna be constant. Why? MA or MG, right? Since it's weight. So weight's the only thing because it's at rest. Now, G is a constant. It's in the name. It's a constant. And the mass is obviously a constant if it's the same block. It's not losing any mass in the process. So what does that mean? My force will remain the same. My force is constant. But what's different is what is the pressure. The pressure is going to be different. Now, here it's telling me, compare the pressures. P is going to be greater than P prime. P prime is, this is going to have pressure P prime. This is going to have pressure P. Now, how do I know? Because what do I know? The pressure is force over area, right? My force is constant. So what it's going to be, my pressure is directly proportional to 1 over area, which means inversely proportional to area, right? My pressure is inversely proportional to my area. That's true. Now, here, my area is this. It's a square, kind of, right? It's a very small square. It's a smallest side, right? What does that mean? My smallest side means my area is going to be the smallest possible. What does that mean? My pressure is going to be the largest possible. Now, that's for A. For A prime, it's its largest side, right? But we know pressure is inversely proportional, so pressure will decrease at A prime, right? So does that mean original pressure is greater than new pressure? Which is what we have. Question 17. Okay, question 17 states, a hydraulic jack system can change the quantity of force exerted between the ends of pistons. A cross-section area of piston A is 1.6 centimeters squared, and that of piston B is what? 14.5 centimeters squared. All right, the downward force on piston A is 100 newtons. Now, something you should know about the hydraulic press. The entire principle of hydraulic press is that the pressure is conserved. So PA here is going to equal to PB. What does that mean? I can say now that F1 over A1 is equal to F2 over A2. right? Perfect. Now, this is easy. This becomes really, really easy. Why? The pressure on piston A. Pressure is force over area. Now, A, I know that the downward force is 100 newtons. My area is 1.6 centimeters squared, but I want to change it to meters squared, so I'm going to do times 10 power minus 4. Remember. Okay? So, doing this will give you 625,000 Pascal. So I'm just going to write 625 times 10 power of 3 Pascal. Now remember, 10 to the power of 3, what does that mean? Kilo, right? So this becomes 625 kilopascal. Now, the pressure on piston B, remember, the entire principle of hydraulic press, this is conserved, so this will be the same. So now, the upward force, remember what I said, F1 over A1 equals F2 over A2. So, F1 is 100, A1 is, actually you can just write this as 625 times 10 power of 3. Right? Because we already found F1 over A1. It's for the pressure of A, right? And we found it in part A. This is 625 kilopascal, right? So you don't need to write, what was it? 100 over 1.6 times 10 power of minus 4 equals F2 over A2 and then cross multiply. No need. You can just do this on an equation solver on the calculator like this, and it's less things for you to write. So this is times 10 power of 3. F2 is what we don't know, and A2 is 14.5 times 10 to the power of minus 3. Okay, now take this up. What are you gonna get? 625 times 10 to the power of 3 into 14.5. This is times 10 to the power of minus 4. Sorry, times 10 to the power of minus 4. 14.5 times 10 to the power of minus 4. 906.3 Newton, but they want nearest integer, so you take 906. Done. Remember, centimeter squared to meter squared is how much? Times 10 to the power of minus 4. Centimeter to cube to meter cubed is how much? Times 10 to the power of minus 6. Okay, now, I'm pretty sure this question is wrong. Because when I saw it for the first time, I'm like, how did they get 101 Pascal? This is atmospheric pressure, which doesn't make sense. So, I don't know. I'm gonna solve it the way I think it's right. And if it's wrong, please someone, like the way I solved it wrong, please someone tell me how, because I don't know myself. So, sorry, so I just had to do something, and I just confirmed with Gemini. Yeah, this is wrong. So, essentially what you do is, here, I don't know if I read the question or not, because I think I was gone for like 15 minutes. So, the pressure at point B to the nearest integer. Now, the pressure at point B is here, right? It's in the water side, so we're going to ignore the oil completely. Now, it's going to be, since this is open, it's going to be pressure is equal to rho G H plus what? The atmospheric pressure. I'm going to call it P0. Okay, now, P is equal to rho of water is 1,000, right? 1,000, 1 times 10 power of 3 times G is 9.8. Height is this height is how much? H2, which is sir, where are you? 18. So into 18 plus 1.01 plus 1.01 times 10 to the power of 5. Now do this, you'll get 1 times 1000 or 1 times 10 power of 3 into 9.8 into 18 plus 1.01 times 10 to the power of 5. Wait, I did something wrong. 1 second. This is 0.18, not 18, 0.1. I keep making the mistake. It's 0.18 because it's in meters. 0.18. This should give me the right answer. Yeah, 102,764. So then divide by 10 to the power of 3. It's 103 kilopascal. This is wrong. 103 kilopascal, not this. Okay? If you do this, you'll get 103, and that's the right answer. Now the density of oil. Okay. For the density of oil, we know that at 2 points, they have the same pressure, right? So PA equals PB. Now, PA, the density is different, right? It's going to be rho GH plus P0, right? Because it's also open-ended, equals to rho G H. Let's call this rho 2 and this rho 1 plus P0. Right now, rho 0 will cancel out, rho 0 will cancel. So what rho 0? P0 cancel out, G and G cancel out. So I'm left with rho 1 H1 equals rho 2 H2. Now, rho 1 is what I want to find, so I'm going to write rho 1 is equal to rho 2 H2 over H1. So, rho 2 is 1000 times H2 is 18, 0.18. Not making the same mistake, 0.18 over 0.28, right? Yeah, 0.28. I'm given 642.85, which is 643. Okay, question 19. A piece of timber, why? Like, who cares? Is floating steadily on the surface of a freshwater lake. The timber has a density of 600 kilogram per meter cubed, while the density is 1000 kilogram per meter cubed. Assuming it's in equilibrium and it's not moving vertically. Okay, I'm gonna give you a trick. Do the density of this over the density of this. You're gonna get 600 over 1000 times 100. Cancel this 0, this 0, this 0, this 0, this 0, this 0. You get 6 times 10, 60%. It's on a computer part you can do it like this, compare the densities. But on the written part, it's basically because it's sigma Fy is equal to 0, right? So it's like this kind of. The timber is like this. So you have the weight and you have the upthrust, right? Now the upthrust is what is rho Vg, right? Rho Vg, and the weight is mg, right? So then G and G cancel out, I believe. One second, let me remember how to do this. Yeah, no, I was right. So sigma Fy is equal to 0. Okay, so then you say the upthrust, or FB, the buoyant force, is equal to the weight, right? And you know that the weight is mg, and m is what is rho v, right? So it's gonna be rho vg is equal to rho v, and then g, right? Because w is mg. This is m, this is m. Now here's what's different, right? Remember, this is the buoyant force is always the rho, the density of the solution, right? So this is the rho of the solution that it's being like being immersed in. This is the volume that's displaced, not the volume of the block, the volume that's displaced. This is the density of the material of the block, right? Let's call it m. And then the volume of that is displaced, that's not displaced, sorry, the volume of the material, right? Or the volume of the block. Listen, it sounds very confusing. Just use it like this, and then you make a ratio. G and G cancel out. So then it's rho of the solution over what do you call it? Over this, or what was it? Over rho m. That's what it is. Rho s over rho m equals to V B, which is the volume of the block, over the volume that's displaced. Okay, now then what are they telling me? How much is actually, what is the volume beneath it, right? So the block, you get it. So then you do this ratio. I'm really tired and I still have like 5 things to get through. So essentially you go through this and then you substitute in values, okay? And then you multiply by 100 because it's a percentage. But as a shortcut, just honestly just do the density of the block, or in this case the timber, over the density of the solution that it's immersed in, which in this case is water. Then multiplied by 100. And on a computer, but they won't ask you written. They'll never ask you this written. But this is just as a shortcut. Okay. 20. Density is defined. Okay, so you see mass of an object per volume. You know this. 21. A diver of mass 60 kg, like, does he have to swim? Swims at a depth of 4.15 meters below. Given the specific gravity of salt water is 1.026. Specific gravity. Don't know if this is specific gravity. What? G is 9.81 and atmospheric pressure is 1.05. Total the pressure, the pressure due to the water on the diver. Okay, pressure is rho. No, it's what was it? Rho GH, not rho VG. So rho is one. What is this? What's a salt? Specific gravity of salt. What on earth is specific? Oh my god. 1 second. I need to figure out what the salt specific gravity is. Okay, so apparently specific gravity just tells you if you want to find the pressure or whatever, you just do the specific gravity times the pressure of or density of water. This is just the density, sorry. It's just to find like the density of salt water. You know that the density of water is 1000, so then multiply 1.026 times 1000. You get 1026. Okay, now you do pressure is rho GH. So 1026 times 4.5 times 9.81, you get 9.81, 45292. So then you divide by 1000, because why they want kilopascal, not pascal, divided by 1000. You get 45.29, 45.3. Now, the total pressure on the diver, so you add atmospheric pressure, which is 1.00. 1 second. You change this back to pascal. How much is it? 453, and then times 10 to the power of 3. 45.3 times 10 power of 3. That's what I'm trying to say. 45.3 times 10 power of 3 pascal, right? Or if you have it on your calculator saved, it's 45292. 45292 pascal, right? Plus 1 times 10 to the power of 5 pascal, you get 145292 kilopascal or pascal. 1 second, let me repeat it. Okay. We found from part A, our pressure is 45.3 kilopascal, right? What does that mean? It is 3,000, like that. Yeah, okay. This would be 1, 2, 3, yes. Pascal, right? Okay, you multiply by 10 to the power of 3. Now, if you want to find the total pressure, it's gonna be the pressure of the water plus the pressure due to the atmosphere. Right? And the atmospheric pressure is 1 times 10 power of 5. This is why I changed it back to Pascal. Look, because they gave to me the P0 in Pascal. So 45,300 plus 1.00 times 10 power of 5. You get 145 145,300 Pascal. Divide by 3 to the nearest integer, they said, because you want to change it to kilopascal, you get 145.3 kilopascal. Take to the nearest integer, it's just 145. Now, please let the last question be something easy, please. Oh my god, it's another one of those. Okay. Oh, no, it's not that bad. What's the pressure due to water of density? This at a depth of 2 if the horizontal top surface is why do I have the surface area? Okay. So we know pressure is rho GH. Is this a trick? Because you don't need this for this. Let me try it. Wait. 1 times 10 to the power of 3 times G is 10 times height is 2. 20,000. So if you want to change this to the way they did times 10 to the power of 4, yeah, it's literally 2.0 times 10 to the power of 4 Pascal. You don't need this. This is useless. This is useless to you. This is not needed unless you're doing force over area, which I think that's why they gave it to you. I don't know how you're gonna find force, but if you somehow do, you use this. But we're not using this because we're using rho GH, and this is the answer. 2.0 times the power 4 using rho GH. Rho G, where is it? GH. Multiply them all together, you'll get 2 times 10 power 4 Pascal. That's the end of the quiz. I'm so sorry for the very bad explanation. I didn't do it before. I normally do my quizzes beforehand, and it's 10 p.m. and I'm honestly tired. I still have like a bio lab report to do. Anyways, goodbye.